The wind on the Giza Plateau hasn't changed in 4 millennia. It still carries the fine, abrasive dust of the Sahara, whipping against the weathered limestone of the Great Pyramid. If you stand at its base and look up, your neck begins to ache long before you reach the summit. It is 481 feet of raw geometric defiance. Even today, with our cranes, our satellites, and our heavy-duty hydraulics, the sheer scale of the Great Pyramid feels like an insult to the limitations of the Bronze Age. We are told the Egyptians had copper chisels, wooden levers, and an army of laborers. But as you run your hand along the joints, gaps so precise that a razor blade cannot slide between them, you realize that labor doesn't explain this. This wasn't just physical endurance. This was a masterclass in civil engineering that shouldn't have been possible. No prickly of the Great Pyramid begins not with the stones, but with the foundation. The Plateau of Giza is not perfectly flat. It's a jagged, uneven slab of limestone bedrock. Before a single block was hauled into place, the architects faced a problem that would humble a modern skyscraper developer. If the base wasn't perfectly level, the entire structure would develop stress fractures as it climbed higher, eventually collapsing under its own massive weight. To solve this, the builders didn't use lasers or spirit levels. They used water. They carved a grid of shallow channels into the bedrock and flooded them. Using the surface of the water as a perfectly level reference point, they chiseled the rock down until it met the waterline, creating a base that is level to within less than an inch across the entire 13-acre footprint. But then, they had to align it. The pyramid is oriented to true north with an accuracy that borders on the impossible, within 3/60ths of a degree. They likely achieved this by tracking the transit of circumpolar stars, marking the ground as those stars crossed a plumb line. It was an exercise in celestial mathematics, turning a pile of stone into a massive, earthbound compass. Term asterisk. Then, there's the logistics of the how. We've all seen the documentaries, the ramps, the pulleys, the sledges. But those are theories for how to move a block. They don't explain how to handle the sheer volume. The Great Pyramid consists of roughly 3 million stone blocks. If you gave the Egyptians 20 years to build it, a generous estimate based on the reign of Khufu, that's one block placed every 2 to 3 minutes, 24 hours a day, 7 days a week. And these weren't just any blocks. Many weigh 2, 5, even 80 tons. The quarries were miles away. Tura limestone for the outer casing, granite for the internal chambers from Aswan, over 500 miles to the south. This wasn't just architecture. It was the world's first hyper-complex supply chain. They were moving massive, multi-ton monoliths across the Nile, dragging them across desert sand that, when wet, acts as a perfect lubricant for sledges. They didn't have the wheel, but they had physics. They turned the friction of the desert into a conveyor belt. Pumpsel snibe asterisk. Step inside, and the engineering shifts from civil to surgical. The interior of the Great Pyramid is a labyrinth of psychological warfare against gravity. Take the King's Chamber. It is housed deep within the structure, beneath millions of tons of limestone. If you just built a room down there, the weight above would crush it like an eggshell. So the architects designed the relieving chambers. Above the ceiling, they placed massive granite slabs, leaning against each other in a V-shape, creating a structural gable that diverts the immense weight of the pyramid outward, away from the chamber itself. They essentially built a stone shock absorber. It's a brilliant, brutalist solution to a problem that wouldn't be fully understood by engineers for another few thousand years. And then, there is the Grand Gallery. It is a miracle of corbelled construction, a long, rising passage where each layer of stone projects slightly inward, creating a smooth, soaring ceiling that stays perfectly centered. It feels like walking through the hull of a ship turned on its side. Why build it this way? It served as a massive mechanical housing for the giant granite plugs used to seal the pyramid after the king was interred. It was a security system, a series of sliding stone doors designed to prevent tomb robbers from ever reaching the heart of the pyramid. They were building a fortress, not just a tomb. They were trying to lock the secrets of a pharaoh away from time itself. Told Gox **. Perhaps the most haunting aspect of the Great Pyramid is the casing. Today it looks like a stepped mountain, but originally it was encased in polished white Tura limestone. It would have been fitted with a capstone, the pyramidion, likely plated in gold or electrum. In the midday sun, the pyramid wouldn't have just been visible, it would have been blinding. It was designed to catch the light, a beacon that could be seen from miles away across the delta. It was an artificial star on Earth. The precision of these casing stones, cut at specific angles to create a smooth, seamless slope, remains the greatest mystery of all. We can replicate the blocks, but we still struggle to replicate the finish. They were working with stones as if they were wood, shaving them down with abrasive sands and copper tools to a mirror-like shine. Mining them down with abrasors at Clockalish Islam. Paul Isbania Mani Matri. Mining them down copper toolbox Tugi clone. Pakлекlis mining them down with abrasors, but go to such lengths. Mining them down without copper to a mini. Aklis Mendonia mini fax. Thou's the wealth of an empire to build a mountain of rock. We often view history through the lens of ego, a king wanting a bigger house than his neighbor. But for the Egyptians, this wasn't about ego. It was about the maintenance of the cosmos. The pyramid was a machine for resurrection. They believed that if the king's spirit could be properly preserved and guided, he would join the gods, the Nile would continue to flood, the crops would grow, and the cycle of life would remain unbroken. The Great Pyramid wasn't a monument to death. It was an insurance policy for life. Noms asterisk. As we look at it today, stripped of its gold and its white limestone skin, we see the bones of the machine. The outer casing is gone, scavenged for medieval mosques and palaces in Cairo. We are left with the core, the structural skeleton. But even in its stripped-down state, it commands a silence that no other building on Earth can replicate. It forces us to confront our own arrogance. We assume we are the peak of ingenuity, that our digital age is the culmination of human intelligence. Yet, standing in the shadow of the Great Pyramid, you realize that humans have always been capable of the impossible. We've always been obsessed with reaching, with building, and with leaving something behind that can withstand the erosion of the wind. The engineers of Giza didn't have computers, they didn't have steel. They had a vision of immortality, and they used the very earth itself to carve that vision into history. 4,000 years later, the dust is still settling, and the pyramid is still standing. Perhaps the greatest engineering secret wasn't the leverage, or the math, or the supply chains. Perhaps it was the simple, terrifying belief that if you build something well enough, the universe will have no choice but to let it stay.